So I am Sivaram, faculty from the Department of Naval Architecture and Offshore Engineering. So in today's session, we are going to see about working of vapor compression refrigeration systems. Basically, refrigeration systems are employed in ships in three places. So place number one, if it is a container ship, it is employed in reefer containers. And place number two, in case of provision rooms, we have rooms for storing provisions, meat room, fish room, and vegetable room. So again, refrigeration system plays its vital role in these provision rooms. And third place where refrigeration system is employed is in case of accommodation part. So coming to refrigeration, see basically refrigeration is nothing but either by lowering the temperature or by increasing the temperature, you are going to maintain an optimum temperature. In one way, we say refrigeration is the process of maintaining the temperature of a surface at a temperature lower than the temperature of surroundings. But the right way to express refrigeration is the process in which you maintain optimum temperature for an enclosed space, thereby prolonging the life of any commodity. There are three important types of refrigeration systems. Vapor compression refrigeration system. The second one is vapor absorption refrigeration system. The third one is thermoelectric refrigeration system. So in today's session, we are going to see about the first type, that is about working of vapor compression refrigeration system. As vapor compression refrigeration system is used almost for 95% of our practical systems. Vapor compression refrigeration system has four major components. So number one, it is compressor. And number two, it is condenser. Number three, it is expansion valve. And number four, it is evaporator. So these are all the four major components present in a vapor compression refrigeration system. And what are all the four processes that takes place in a refrigeration system is compression in a compressor, condensation in a condenser, expansion in an expansion valve, and evaporation in an evaporator. So these are all the four processes which takes place in a vapor compression refrigeration system. The working fluid used in this system is refrigerant. So refrigerant can change its phase from vapor to liquid and liquid to vapor. Earlier we used water as a refrigerant. I can say before 300 to 400 years in a system called a steam jet refrigeration system. But water freezes at zero. Then thereon, since water had these limitations and steam jet refrigeration system had these limitations, we moved into chemicals refrigerants, and right now we are going on with vapor compression refrigeration system. Coming to the first component, compression. So compression is generally isentropic in nature, where entropy remains constant. So a compressor cannot compress a liquid, because if liquid enters inside a compressor, liquids are incompressible. So if liquid enters inside a compressor, liquid sludging is likely to take place. So always refrigerant enters the compressor in vapor form as a low pressure vapor. And inside compressor, it undergoes compression. Compression is nothing but decrease in volume. Obviously, when you decrease volume, pressure will increase and temperature will increase. So refrigerant which enters as a low pressure vapor leaves as a high pressure, high temperature superheated vapor. So this high pressure, high temperature superheated vapor, next component, condenser. And condenser, as the name implies, condensation takes place. So for condensing, I need a cooling medium. Either the cooling medium can be air. As air-cooled condensers which are present in fridges at the backside, you can see natural convection air-cooled condenser which do not have any fan. Or else the condensers of a split type air conditioning systems where you see a fan for forcing air. So you need a cooling medium to condense refrigerant. Either the cooling medium, if the cooling medium is air, it is an air-cooled condenser. If the cooling medium is water as employed in a ship, that is a shell and tube water cooled condenser, it is a water cooled condenser. So high pressure, high temperature superheated vapor, it enters inside the compressor, and as a result of this cooling medium, the vapor condenses into liquid. But there is no significant variation in pressure. Why there is no significant variation in pressure is tube area is same. So when you need to change the pressure, it is force acting per unit area. So either you have to vary the force or else you have to vary the area. So at condenser inlet and outlet, when you compare the pressures, there is no significant change in pressure. So refrigerant which enters as a high pressure, high temperature superheated vapor leaves as a high pressure liquid. Then in case if the volume of refrigerant is very high, we use a tank called receiver tank to collect the liquid. Then refrigerant moves to expansion device. Before its entry into expansion device, it passes through a component called filter dryer. So what is this filter dryer? What is the use of this filter dryer is, filter dryer is used to filter the moisture content present in the refrigerant. Why moisture needs to be removed is, the temperature at expansion valve outlet, I can say either it can be 1 degree or 2 degree. So at 1 degree or 2 degree, if refrigerant enters your expansion valve with the moisture content, the moisture will freeze into ice. In order to avoid ice formation inside the expansion valve, filter dryer is employed before expansion valve to remove the moisture content present in the refrigerant. So filter dryer. Inside filter dryer, a substance called silica gel is employed. Silica gel is nothing but a liquid desiccant. So when refrigerant passes over the silica gel, the unique nature of this silica gel is it can hold 28% of its weight by water, moisture content. Say I have 1 kg of silica gel. The 1 kg of silica gel can absorb 280 grams of moisture. So 1 kg of silica gel, okay, after absorbing 280 grams of moisture, it will be 1.280 kilograms in weight. So 27% of its weight, it can absorb moisture content. And by using silica gel in the filter dryer, moisture or water vapor content present in refrigerant is completely removed, and moisture free refrigerant goes to expansion device. Either the expansion device can be a capillary tube as used in systems below 1.5 ton, or else it can be a thermostatic expansion valve, or else it can be a solenoid valve. So the function of this expansion device, it is used to expand the refrigerant. So expand in the sense, first the refrigerant flows from large area to small area. The refrigerant undergoes sudden expansion from small area to large area. When refrigerant undergoes sudden expansion from small to large area, what happens is pressure reduces drastically, because pressure is forced by area. Obviously, when area increases, pressure will decrease. So pressure reduces. When pressure reduces, temperature also reduces. So high pressure liquid which enters the expansion valve after expansion leaves as a low pressure, low temperature liquid vapor mixture. So the low pressure, low temperature liquid vapor mixture passes through the evaporator coil. And in evaporator coil is nothing but, I can say, if you take a split type AC, it has 2 units, indoor unit and outdoor unit. The indoor unit which is present inside the room is evaporator, and the outdoor unit where you can see a box, that will have compressor and condenser. So say initially the room is at 28 degree, refrigerant passes through the coil at 8 degree. The air present in the room will touch the coil. Obviously, energy will get transferred from 28 degrees Celsius room air which is present in the room which is at 28 degree to the refrigerant that is flowing inside the coil at 8 degree. As a result of which the room temperature reduces, we get cooling effect in the evaporator region due to the low temperature, low pressure refrigerant flowing across the evaporator. In case if liquid tries to enter the compressor, in between evaporator outlet and in between compressor inlet, there will be a component called accumulator. This accumulator will accumulate the liquid and only vapor will be allowed to enter inside the compressor. So put together, first it starts with 1 to 2 compression in a compressor, and 2 to 3 condensation in a condenser, and 3 to 4 it is expansion in a expansion valve. And the next one, the last one is nothing but evaporation, and this 4 process, this gets repeated again and again. Compression, which is followed by condensation, expansion and evaporation. So this is how a simple vapor compression refrigeration system works. In the upcoming sessions, we will see in detail about all these components in detail. Thank you.